What is net_graph? It's a CSGO performance monitoring tool which is built within the game. Here is how you activate it. Make sure you have your developer console enabled by going to the game settings. Next, open your console and type in net_graph space 1. This brings about a series of numbers on the bottom right of the screen. Let's take a snapshot of it. The first row gives information about your PC. The second row gives information about the connection of your PC with the game server. And the third row gives information about the server you are connected to. But what do these numbers mean? And how do you interpret it? Let's see one by one. Frames per second. FPS is the number of frames rendered by your PC each second. Take a look at this FPS simulator. Even though the speed of the UFO moving from left to right is the same, since the number of frames used to represent this motion increases, the animation becomes more smoother and less jittery. Similarly, in CSGO, higher FPS results in smoother gameplay. But this property doesn't remain linear throughout. Constraints like monitor refresh rate, server config, etc. caps the FPS to an integer above which visible change is quite negligible. If you are getting low FPS even after upgrading few parts of a PC, it may be because of bottlenecking. Look at this picture. You have an uber fast RAM and an GPU, but your CPU is slow. This results in capping the performance of your PC to that of the CPU. So make sure you save up to either upgrade all components of your PC or buy a new one altogether to get the most out of it. Since FPS is a factor of multiple parts of a PC, in reality it is not a constant number, but keeps varying. And that variation is measured by the var depicted in the first row of the net_graph utility. Assume that you have 300 FPS. It takes 3.33 milliseconds to generate each frame. If you have 250 FPS, it means it takes 4 milliseconds to generate each frame. So we can understand that FPS can also be represented using the time period of generating the frame. Now if you take this variation of time and find the standard deviation of it over the last 1000 frames, you get the value of var. Ideally this should be low, but if you have high variance, you can use FPS_max to limit the max FPS of your client or your PC to reduce the load and maintain a small variation. Let's try to get a brief overview of the server-client communication happening every time you play matchmaking. Imagine you have two PCs. The one at Gaben's house on the left is the default server. You're trying to connect from your client PC, which is on the right side. Now all communications happen in form of packets containing gameplay info. Each second an agreed number of packets is transferred between the server and client. Here 3 packets are transferred, so we can alternatively tell tick rate is 3, but we will get into that later. Now let's see what is ping or latency. Time taken for a packet to reach the server is referred to as ping. It is measured in milliseconds. Higher ping results in jittery gameplay, late hit registrations, making the game unplayable. If your internet is slow or the server is far away, this usually happens. Next up, loss. In our previous example, when we were trying to send 3 packets to the server, if due to some reason one of the packet doesn't reach the destination, this results in packet loss. We lost 1 packet while sending 3. So simply, the loss is 1/3, or in percentage, 33%. Besides your ISP losing your packets, even if the server is slow, it can get congested and can reject the incoming packets, resulting in a spike in loss percentage. Let's talk about choke. If the number of incoming packets exceed the outgoing ones, the network is said to be choked. In CSGO, if the server is spamming the game more than it can handle, choke happens. It is similar to loss, but the packet sent by the server is now rejected by you, the client. Let's see a real-time example. Now I'll set the rate or the maximum bytes per second the game can handle to 20k, the minimum value. Now, if I move around, Watch as the choke percentage rise like wildfire. This is happening because the game is trying to bite more packets than it can chew or process, in other words. Now, if I change the rate back to 128K, the choke plummets to 0% as I move around, right where we want it. Next is tick rate and SV. We saw that tick rate corresponds to the number of packets sent each second to and fro between the client and server. In official it is 64, and in third party like Faceit or Strong, it would be 128. Just like FPS, tick rate can also be measured in time period rather than frequency. For a 64 tick config, the server would receive one packet every 15.625 millisecond, and for a 128 tick config, it would be 7.8 millisecond. Now here is a simple timeline of the operation at a 128 tick server. The server receives a new packet every 7.8 millisecond, and the red region between this time gap would be the time taken by the server to analyze the received info and to do the necessary calculation regarding the game at hand. This time is not constant and depends on the packet, and the standard deviation of 50 such passed packets is the SV value. For proper operation, the red region or the SV value should be less than the time period of the server, in our case 7.8 millisecond. This is made sure because the server should be free to receive the new packet and should not be withholded by processing the older one. If not maintained, it will result in rejecting the new packet and ultimately leading to loss. Lastly, server var. Let's jump back to our timeline. Imagine that the first packet is successfully processed at the time of 3 milliseconds. Now the server is simply told to go to sleep for another 4.8 milliseconds till a new packet arrives at the beginning of the next cycle. In reality, the server doesn't sleep for the exact specified time, and there is a variation in microseconds. The standard deviation of this variation of the expected to the actual sleep time over the last 1000 frames is given by the server var on the third row. In other words, var is the measure of the sleep accuracy. But why is this needed for us? If we make sure that the processing time is less than the expected time period minus the maximum deviation, you can maintain a stable server. So next time you connect to a 128 tick server, if the SV value is less than 7.8 millisecond minus var, then the server is working as intended and you're good to go. Now that you have a brief idea about the various parameters of this utility, the next time you mess up like Carrigan does in this classic age-old clip, just blame it on the incompetence of the nanosleep function on the server end, just like I do most of the times I get CSGO. That's it for this video guys. Take care and don't forget to subscribe.